Hi, in this lecture you will learn the persistent state of package objects. Actually, I had mentioned about that before, but in this lecture I will expand it and show it more detailed with some examples. Because this subject is important, and if you don't know that, you may fall into some logical errors. You may have some unintentional results, and if you don't know this property, it will be hard to understand the reason. Alright, I have told a few times before, but this is important. So I will explain one more time now. We know that we have two types of memory areas in the database. The first one is Program Global Area or Private Global Area, abbreviated as PGA, or User Global Area, abbreviated as UGA. These names refer to the same memory. These are just different names called by different people. This memory area stores the objects, variables, and codes of a single user in a session. So this memory area is private for a user, and any others cannot see or touch to these objects. Every user has its own PGAs. The second memory area is SGA. This is called as System Global Area, or some call as Shared Global Area. This area stores the shared objects, values, codes, packages, etc. among all the users. Alright, now let's come to our subject. We know that when a package is first referenced, unlike the stored subprograms, the whole package is copied into the memory directly. But in here, there is something important. This is really important. So I want you to listen carefully. While the package is being copied, the public objects and the public variables of that package is copied into the PGA, but the subprograms are copied into the SGA. So these variables and objects are now specific for that session. And that means if you change a variable in your session, the value is overridden only for your session. However, if another user calls the same variable, he or she will have the initial value of that variable, because every user has his or her own variables. So your changes will not affect the others. But the change will live until your session ends. Try to understand that well. Let me explain that with a scenario. Let's say the variable x in our package is initialized by 10 by default, and you change that value in your session to 20. So you will see that variable by 20 anymore, but other users will still see as 10 because you changed only the variable in your PGA. Other users who refer to that package have their own variable access. Another main and important thing in here is, even if you do not do anything about the package for a while, when you first refer to that variable x, you will still see that as 20 because it is stored in your PGA until you end your session or the package is recompiled. However, the package creator can change this state. I will show you how to do that too. But now let's continue with the next page and summarize it before making the examples. A package is loaded into the SGA and PGA partially when we first call one of our package components. That component can be anything in your package. We saw that in our previous lecture. Variables and objects are stored in your PGAs. Every user who calls a package component will have the variables and the objects in the package in their PGAs. But do not confuse about that. Only the public ones. The private ones cannot be called outside of the package, so they are stored in the SGA. These objects are stored in the PGA until your session ends. But there is one more thing about the packages. If a package is recompiled while you are using that package, the whole package is reloaded into your memory on the first usage. So the state of these objects will be refreshed. Your changes will be gone. This is also important. all the objects are unique for your session, so your changes will not affect the others. Since you cannot change the subprograms of the packages, they are stored in the SGA, so every user calls these subprograms not from their PGAs but the shared areas SGAs. Now, here is the very new thing of that lecture. We can change this option. I mean, we can make the variables and the other objects to be stored in the SGA instead of storing in the PGA. Why do we do that? Actually, there is one main reason. It is saving some memory. Because most of the times your packages will be used by so many users. So every variable of your packages will be copied into all of the users' PGAs who use that package. So if you don't need the state of these variables to be stored, you can do that. So these variables will all be stored in the SGA. So they will be copied into only one place. All serially reusable packages are pooled in the SGA, so you save memory. Or maybe you don't want to write constant keyword for all the variables. Actually, this is not true, because changing the state of packages to serially reusable does not make the variables constant, because they will be returned to its initial status as soon as the call to the server ends. I will show you that. Alright, so we do that for saving some memory, and it will be very useful if you have so many variables and if your package is used by a lot of users and if you need memory. So how do we do that? We do that by adding serially reusable property to our packages. So how? We add pragma serially reusable keywords to our package specifications. But the important thing here is, if you have the body, you need to add that to the body too. So what is that pragma keyword? Pragma is a compiler directive. So when the compiler sees pragma keyword, it knows that there is a command for the compiler. This serially reusable keyword tells to the compiler that compile the package as its variables will be stored in the SGA. So if a package has the pragma serially reusable keyword, the variables will be stored in the SGA instead of PGAs. So right after the call to the server ends, the variables and objects are initialized to their default values or to null. However, making a package as serially reusable has also some cons. If you set your package as serially reusable, you cannot access to this package from the triggers and the subprograms called from SQL statements. So think twice before making a package serially reusable. Perfect. Now it's time to make some examples. So let's open up the SQL Developer then. Now, we know that we have a bodiless package, constants package. We have variables, cursors, etc. in that package. We have created this package for using some constants. But do not confuse about that, because these variables are not constants actually. I will show you how to make them constant. Alright, to see the state of these variables, we need to test by two different users. So let's open up two different worksheets side by side. We have two users for now, HR and my user. So let's open up them side by side then. And select New Document tab group. At first, let's print the value of vSalaryIncrease variable with HR user. Execute dbms output dot put line constants pkg dot vSalaryIncrease. Now let's run it. As you can see, the initial value of that variable is printed on the screen, 0.04. Now, this is our first usage. So these variables are stored into our PGA right now. Since there is not any subprogram or our package is not set as serially reusable, nothing is stored into the SGA for now. Alright, now let's print that with the my user then. So let's copy paste and run. As you can see, we had an error because this package is created under the HR schema. So we need to write the HR prefix before the package name. Now let's clear up and run it. But we still have an error because since this package is created under HR schema, my user needs to have the related privilege to run this package or to reach to any component of that package. We can grant that privilege by a DBA user or by HR user itself. So let's do it with the HR user. We need to grant the execute privilege for the packages. But there is something important here. Granting the privilege is done for the whole package. That means you cannot grant for a specific subprogram or a variable of the package. If you grant the execute privilege to a user, this user can now reach or run all the components of that package. Do not forget that. So let's grant the execute privilege to the my user then. Actually, these privileges are granted by the DBAs most of the time. They don't let you to grant or revoke something, but it will be good for you to know. So let's type it. Grant execute on constants pkg to my user. To revoke a privilege, we write like that. Revoke execute on constants pkg from my user. Great. This revoke statement is for just to show. So now let's run the grant command. And execute the put line procedure by the my user now. As you can see, now it can see and use that package. And the value is 0.04. The first zero is not written because it is a number and put line does not write the whole number if it is 0. Perfect. Now it's time to see the persistent state of that variable. Now let's change the value of that variable by a user. For example, let's do it with the HR user. Begin constants pkg dot v salary increase is equal to, let's say, 5. Now let's copy this and paste in here and write end. Now we need to delete the execute command here because we use the execute command if we will execute a procedure standalone. If you write begin end keyword, you directly write the procedures. And put line is a procedure, so let's delete execute command now. Now let's execute it. As you can see, it is overridden to 5 now. So let's run the dbms output in the my user worksheet now. Did you see that? Even if we change the value of the variable in our package, it is still the same on my user's PGA. Do not confuse about that. It is not about commit or something. To see that, let's commit from the HR user and run that dbms output in my user again. As you can see, it is still 0.04 because we know that Commit and rollback is for inserts, updates, and deletes. The variable value change cannot be committed. Do not confuse about that. Alright, now we saw that the values of variables in packages are specific for every user. All the users except HR will see the initial value if they don't change the value. So let's change the value in my user and see the DBMS output. Let's copy that and paste in here and write HR prefix before our package name and run it. Let's change this value to 3 now and run again. As you can see, the value in my user is 3 now. So now I will show you something important. What if we execute only the DBMS output in HR schema without changing the value? What will happen then? Will we see 0, 4, or will we see 5 or 3? Let's do it then. As you can see, it is still 5. So this value will live until our session. To see that better, let's disconnect and reconnect and run that code again. But before running, let me warn you. Reconnect does not mean disconnect and connect. If it is already connected, it will not disconnect and reconnect. So if we click on reconnect, it won't work for us now. Alright, as we created a new session by disconnecting and reconnecting, let's run our DBMS output again. As you can see, since our package is reloaded into our memory, our variable is 0.04 again. Let's check the value in my user again. So let's run the single execute command. As you can see, it is not affected. So let me enlighten you about something. When a package is first called by any user, the objects to be loaded into SGA is loaded once. Then when you start a session, only the public variables and public objects are taken and loaded into your PGA. It does not affect the SGA or any other user's PGAs. So do not confuse about that. The package components are loaded into the SGA only for once with the first call of a single user. The other calls will not have any effect on SGA. It will only be recopied if the structure of that package changes. So the main thing in here is, if you change the value of any variable of a package, whether with or without using the subprograms, this new value will stay same in your session. So if you forget that change, maybe so many days later, when you use that variable in somewhere, you may assume that it will have the initialized value. Or you may forget the last value of that variable. And this may cause some logical mistakes, and you may have some unintentional results on your business. Alright, I think that's enough for the persistent state of variables. This is the end of this lecture. See you in the next lectures.